Okay, let's continue our tutorial. I believe we left at step 7, and most of the instructions actually do say what to do. But I'm still going to walk you through it to do a simple code injection. So basically what it means is that we're going to find whatever the instruction is in assembly, right? The assembly equivalent of, let's say, a decrease in your health, and replace it with an instruction that you want, right? So this is a simple kind of replacing of an instruction. And in kind of more cheat engine terms, it would be basically injecting your code over the code that we want, right? And the way it works is, you know, the memory of the original code, and you replace it with the exact memory of the other one for safety. I don't think it actually explains it here. Yeah, I don't think it will actually explain to you how much you really need in this scenario. This will be like a typical kind of an example. What are you going to try to do? And in this example, we're actually trying to modify the instructions to not add, but actually subtract, right? Okay, so let's try to figure this out. So first, let's do the basic thing. We're searching for 96. Right, let's go down. There's 95 already, but for the sake, let's search again. 95, right? Let's hit again to see if it changes. Yeah, okay, that is our correct value. Now, let's see what writes to it, right? So what access it means basically what just looks at the value, right? Or whatever looks at it. But what writes to it, you see the instruction that actually changes what's inside of it. You can press F6. It will attach automatically a debugger. So in a protected game, this will not work, but in this example, there's nothing to protect it. And let's do hit me again. Okay, so here's our instruction. So we have sub dword pointer, right? So this is gonna sub. The instruction is basically means subtract. The other instructions you might see would be add or compare. Actually, let's look up operation codes in assembly, kind of give you different types. And these are universal for the most part, but in terms of like naming, but sometimes you'll have different instructions depending on what kind of architecture you have, what kind of CPU you have, and how it's set up. But the basic ones are basically add, subtract, push, move for moving memory, XOR, basically just like a comparison type of thing, jump to basically jump into other parts of the code. I will explain this more in like the digital, I guess this will be called digital systems, if you want to look at like the theory behind all this. But when we do coding, this comes up a lot, and we will actually show how it works in more detail. But for now, just think of it, there's sub, there's compare, there's move, there's call, push, and add, jump. Like these are, you will see these codes more often. The more you code, the more you see these opcodes pop up. So anyways, we know that it's a sub, so it's subtracting 0, 1 right now, right? You can see the 0, 1. It's subtracting 0, 1, and this is from the address plus its offset. It's not actually subtracting at the address. Think of it like that's the head of the address, the head of the structure, but it's subtracting it from an offset of that address, right? So it's like, think of it like here's the house of the mayor, but it's subtracting what is a CE0 down of an offset down the house of the street, right? And subtracting 0, 1. So we know that we have this. In a disassembler, we can even see the subtraction, right? Base address with all this stuff. And what we're going to try to do is we're going to modify the instruction that does the subtracting. And you can do that by going into tools and going into auto assemble, right? So you're going to auto assemble a code injection. You can also press Control A. I think they tell you this. Yeah, you can press Control A on it. It'll give you this open window, and we will use a typical code injection template, right? There's other kind of examples. AOB, think of it like a scan. For memory, full injection is like full control of the memory going through in. But we're going to do a simple one on what address do you want to jump, right? So yeah, you have to have the base local address, which you can see right here, right? You can actually even tell by this. So this is actually not the correct one in terms of like how it works, but yeah, this is what you're trying to kind of push through. So here's what we have. We have allocation, right? So everything you do has some memory, right? So we're trying to allocate new memory, 248, to this base address plus the offset. And then we'll return it here. Now, basically, this is all the standard template for how Cheat Engine works, right? So it's not typical how you would code, but it's basically the easiest way for you to understand how it works. So exit, right? Return here. It will jump to return here section, right here. So that is, I guess, the original, the next code after it works. The original code, right? This is the instruction that we're trying to change, the one that you found in here, right? And the new memory is what you're trying to overwrite it with, right? They actually even explain it to you. This is the allocated memory. And this right here is how much memory are you allocating for it, right? You have read and write access. In normal scenarios, this might be restricted, so it'd be actually harder to do it this way. For games that actually have protection, most games that are single player don't. But in some cases, this would be protected, and you'll have to find different ways of actually going around it. But that's more advanced. In these scenarios, in most games, or at least that are single player, you will not have trouble at least overwriting the memory or instruction that already exist. Anyways, going a bit off on a tangent, we're trying to replace this. They explain it here, but right? Let's remove this. And to comment out, you just do /, right? That's gonna comment out the code, so it's not gonna run. It's just gonna look like a comment, right? It's not gonna, the compiler won't look at this. It will just look at new memory, it'll look at this. Now, what you did, right, is basically this kind of explains what it's doing. First, it's allocating new memory at this section. It's returning here, right? Returning to the start after the allocation. It's gonna run the new memory, and it's gonna run the original code. So basically, what this thing does is, here's the original code. Do you want to do something with it? If not, leave it the way it is. Here's the new memory that's going to be running before it, right? And this is how much memory you allocated for it. And here's the instruction that's going to do. So what we just did is essentially we doubled this instruction. So this is going to give -1 and another -1. So you'll have -2. So for example, if I do this, right? I do run it like this, right? It added a new instruction, right? As you can see, it added another duplicate instruction above ours. You press hit me, it'll be now 91, 89, but we don't want to do that. And delete the line in decrease your file. Okay, yeah, so this is just the recommendation. Yeah, so what happens is you could either delete this instruction, right? Just literally deleting it, or, which is a better practice, just comment it out so that you know this was the original one. This was the original code. I don't know, does it follow? Yeah, it follows like a C++ template, right? So you can do it like this, or, right, something like this, right? You can remove it. And in this scenario, well, we want to change how this instruction works, right? So we add instead of subtract. So basically what we did on top of this, we created a new, can you actually even show it to you when it's not commented out? So what we did is on top of the original code, right, which is here, we added this new instruction. that does this, while we continue with the original. And if you press hit me, nothing will happen, right? So what they're asking us to do, if I'm not mistaken, is to increase it by 2. And we will just change this to 2 right here. And I think that should be it. Yeah, that should be it. If we do that. Oh, sorry, did not execute the code. Right? Now it increases by 2. So this is a simple way to basically inject your own, think of it to inject your own process right here, your own command to where you want it. And the whole point of the auto assembler, right, and the tools is just to quickly do it for you, like a little script that will do that for you. And you can play around with these things, right, to kind of give you a better sense of it. But essentially what we did is just kind of get you started on how would you start adding your own instructions that you wanted to do. And if you already know the instruction that you want to change, you yourself can make a code to remove that instruction or replace that instruction with yours or modify the original instruction, right? You don't have to do the, right? You don't have to do the, right? You don't have to do the original one, right? Like you don't have to put new memory. Technically, if you deallocate this, right, you put alloc this, just, you can modify how the instruction runs. Okay. Now we are, yeah, okay, so now we're in multi-level pointers. So similarly, in the past, right, we checked how a pointer works. And in this one, we'll actually explain how a pointer in more realistic scenario will work. This is a manual way of doing things. You will actually learn more advanced ways of finding these pointers. But this is a manual way to go back in a pointer, and it will teach you how to get the actual address every time you launch the game. In more realistic scenario, right? The pointer usually is not one level. Usually it's a couple levels. And it's not necessarily level 4, or 3, or 2, it's random. In some rare occasions, you might get even the base address just off the value, but that's a lot rare. That's more in simple, more very, very simple games. Even in, honestly, even in simple games, they'll still use a pointer to it. So anyways, and increase the address to 500. Okay, so here's what we're going to do. We first need to look for this value, 476. First scan. Let's change the value. It's this one. Okay. So now we know, and I'm going to write this as value, right? And it'll be easier to understand this way. We're going to see if I know what writes to this address. You can also do what accesses it, right? So when you're gonna start using pointers, you actually need to look at what accesses it, rather what writes to it, because the access just looks at what tries to get information and go through. So think of it like, hey, does this go through this pipe? When you do write, you're specifically asking, hey, does something change within the pipe? And in some cases, like when you're looking for pointers backwards, you're not going to see anything that being changed in the addresses. The addresses stay the same, but they're just being accessed to go to the end, which is the value. So the value can be changed when you change the value. But sometimes you can just look at addresses, not change them, to go to the next step, right? To go to the next floor. And the only way you can see if something accesses it is by doing F5, right? You want to see what's accessing rather than what address. When something writes, it also accesses it. It first looks at it and then it changes it. So that's why, what's the big distinction between these two functions. So in this case, for the value, we'll do what writes, because that will actually still give us the same thing. And we do change pointer. Okay, so here's what we have. We have move EX, think of it like the bottom portion of REX. Okay, we have to actually stop the code, but move the REX, the bottom portion of it, which is the EX, into RSI, but don't move it into the address of RSI. Move it into the address, but 18 blocks down, an offset of 18. And what I want you to do is start recording this. So first offset would be level 1, right? And the offset would be 0x18, right? That's your offset. And the reason why we do 0x16, this is the hexadecimal notation. So we know that this is a hexadecimal. If you did this, this means decimal. This would be hexadecimal. You're trying to point it out that this is a hexadecimal. So we know it's 18, right? So let's keep that right here. And in the same time, I'm going to start explaining what you're actually doing. So let's say we do, why is it? Okay. We'll do value, right? And what's our value that we had? 1470, right? We have a value 1417, right? And then do a shape. Oh, okay, we can do it like this. Thank God. Value 1417, right? With the address what was our address, right? The address of this. So think of this as our house, right? We have the address of our house and we have the value, what's inside of it, right? Like what's inside the house? Value 1417. This is inside our house. Now, what is a pointer? What we just did, right? We found that something is happening. Someone is going in, changing our value, right? So someone is moving things in and out of our house. And that's why our value is changing, right? You don't have to worry about what it's doing. It's just someone is doing that. Some instruction is causing two registers to be moving things around. What is moving, how it's moving, don't worry about it right now. The idea is you're trying to backtrack it. If you do know the value, it makes it a little bit easier too, but you don't need to, right? We just need to focus on the pointers itself. So what are you doing? So we know, and let's see if can I do an arrow. And let's see, right? We know. Can I actually select it all? Right. Be easier this way. Actually, no, let's do it at the bottom. Looking at my screen would be easier this way. Yeah. Okay. And then let's copy. Think of it like offset level 1. Do the same thing. And actually what I'm gonna do, let's make it like orange so it'd be a little bit easier to tell where like the head of it. So think of it, this is you're at the head, the master location of it. I'm surprised that I can't do this, but okay. You gotta get used to this. And here, the value is your address, right? Is this. bit. And let's do it address 2, 1. All right. You know what? I'm just gonna do the full copy. Be easier this way. All right. Here's your address. Now, this is basically what a pointer is. You have an address of the memory, and that memory holds a specific amount of data, which holds what value you need. And that value is going to be 1417. The address that holds that pointer, the pointer that points to this location of memory, right? It has the value of this address so that it knows where to look for, right? But it also has its own address in the memory. Address 2, right? Offset level 1. But it's not the head address of the pointer that we're looking for, right? It's just a location offsetted from the struct to look for the address inside, but that's not the main pointer to it, right? And let's go back into Cheat Engine, right? How do we figure out the base pointer towards it, right? Like the first level of pointer. Well, we take our calculator. Let's copy this, right? Correct, right? And we know it's 18. So whatever the address we're looking for it's the x plus 18 equals this hexadecimal, right? And you have to be in hexadecimal. And we minus it now, right? To figure out whatever the x is. So this will be our new address. So think of it. When you search for this, right? Let me do it like this. Okay, I made a little mistake for some reason. It's 18, so I don't know why I put 10. So we took 18, right? So sometimes you gotta double check yourself. 18, and this will be the address of what we're looking for, right? So first you do a new search. Oh, yeah, when you do copies, make sure that you remove this. And now we have, think of it like level 1, right? So what did we just do? To explain it better over here, I can draw it out actually. What you've done is you're trying to do something like this. You have the address, right? And that address has some kind of value. Trying to go back into it. Trying to go back. Think of it like levels back into what you're looking for. And the simplest way to kind of explain this is, let's say our value is 1417, right? Right? A pointer is essentially kind of goes back by addresses and offsets, And it will go something like this, since it's a level 4 pointer, right? So the address will be here, right? Let's call this address 1, the one we call it here, address 1. There will be some kind of offset 1, plus the address of plus another address, right? Will equal the base address of the first level of your pointer. So this is level 1. We're at level 1 right here. Level 1 kind of pointer. Right, this section right here. So essentially the way it works is there is some base address. You take that address, you add it an offset, right? And I think correctly wrote this here. Not liking it, okay. And this kind of think of it like a point. It points to it. It doesn't equal to it. Base address, you add the address plus an offset, and it will give you the address of the house we're looking for. And you essentially repeat this over and over, right? Until you get the static address, right? It'll be the same thing, offset 2, right? Address. Something like that would be better to explain. Yeah. Right, so this will be offset level 1, right? Offset level 1, and then it will go back and say, right? And this will be address 2, right? And this will equal once again into another base address. So think of it like here. This would be a base 3. Think of address 2 and 3 are the same thing, right? They have the same address kind of inside of it, basically. Right, and you will continue this until you find the original one. Right, so that's what I'm kind of trying to teach. And here we connect. And this will be our base 1, right? I guess if you want to call that. Or it would be kind of address 2 actually. Sorry. Value. Let's start with value. I don't know why I wrote it inside, but would be address 2. Like so. So it'll be an address 2. So this is the first level, right? Reason the way it's set up this way is a lot of times things are in a structure. Things are in sections of memory, and they're not directly linked to each other. They're kind of in offsets. And you're basically trying to kind of spiderweb back to the original module, right? And what you're doing when you're doing the pointers is that, hey, you're instructing the cheat engine, hey, let's say I shut down the game. If I turn it on, how would I go back to this address, right? The game launches, right? It has the Windows gives its own module address, like base address, which is like your DLL or EXE or whatever it's using. It follows a specific path to create a structure for your character with this, and then it creates it and sets the value for it. Well, what's the path that it's going to follow? And sometimes it can reach to this house in different ways, and you have to multiple times try to figure out what's the best way, right? It could reach the value, let's say in the middle of a menu, but that's not the correct way, like through the UI or something, right? You want to do it through the game engine, like where it stores values for health and your addresses of other people's health, right? You don't want it to go through another means of getting it, because maybe in some scenarios, the access of it might be only available through like UI, right? Or through like the training area or whatever it is, right? So you kind of need to figure out the best way. Now, in most cases, you don't need to go think too deep on this, but you're essentially trying to figure out right now how, when I start the game, from the original address where the memory starts, or the module address where memory starts, what path does it take through the memory to get to the value I want, right? Because every time you launch the game, it'll be different, but the pattern for the most part is the same. At least in single player games, it's roughly the same every single time, right? At least the same path. So this is what you're trying to figure out. Now, we know the offset here is 0, 18, right? So to reach here, one must plus whatever the address in this value plus 18 to get into here. Right? So let's go back into this. Right? So we just did level 1. Okay. We know, let's say right here, we know the value right here is 0.18. It's on an offset of 18, right? We go back here. I don't like, oh, we should kind of stayed on top, but the address of it is now this. And the value inside of it is this. So, right, everything has its own address, so I know it gets confusing, but essentially what we did, oh, I should not write like this, be the value 2 plus, right, because with so many addresses, it's hard to kind of explain, you know, the difference between the two. Like sometimes they hold an address, sometimes hold a value. So think of when I say value is whatever's inside the container, inside the memory. And sometimes whatever's storing is just an address. Sometimes it's storing a value that you need. Now, what did we just do? You have an offset, right? We'll do it like that, right? We'll put it at the bottom. And we write the address, but we'll do like offset 1, right? It'll be easier this way to understand it. I don't want to name it any other way, but you have something like this. Okay, to kind of make it a little bit easier to understand, I'm going to change the color to, let's say, green. So think of this not necessarily like a storage, but something that gives direction, right? So this is a house, and this is more like a direction, right? It essentially is a pointer. It's essentially a pointer to get to where you want. This is a storage. This is a storage. What it does is essentially, here's my house right here. I want to get back to the house, to the main house that gave directions to my house, right? Well, think of it like a sign, right? It tells you, hey, I know this house has the value of your, it knows the value of inside the house is the value of your address, right? So whatever's inside the house is just a big giant poster that says, here's the house of health. Health is at this house, right? Well, value 2, right here, it's not directly the house value, right? Think of it, it has like a neighborhood, and it points to the neighborhood that your houses are in. But what you want is your house. You don't want any other houses. You want your houses, right? So the value will, most of the time, what this means is that it actually is pointing to the head one, right? To the head of the section you're from or something, right? To this entire neighborhood, right? But we don't need to the head. We need to know where the head starts, where the neighborhood starts, and we need to get to it, but not from this, but not to the start of it. We need to get to the specific section of memory that you need, and you do that with an offset. So it knows, okay, hey, the pointer knows, hey, we are wanting to go to this section of memory, right? To the start of the section of memory, but I don't want like the start of it. I want the specific point of it. And the pointer, its main job is to take the start of the neighborhood, right? The start of the memory, and then add the offset, right? What's the next house on the street up to 0x18, and how it reaches it, right? So think of it like, here's my street address, and here is the house number, right? Kind of like, in a way, you kind of have to like wrap your hand around it, but this is essentially kind of directions. That's what pointer is. It's just directions. It's a passageway for this area of memory to know where this area of memory is, right? That is what a pointer basically does. These are actually the storage, right, where they store values. And this is kind of what the pointer is doing. It's not actually storage of data or anything like that. This is just what the pointer is doing. When you code, when you use pointers C++, this is the function of the pointers. Think of it like signs, right? They're signs. They're not houses. They're like signs to point you to where you need to go. And what we just did is level 1. Like we did level 1 pointer in a way, right? Now sometimes, which you will see in the next example, you don't even have to have like a direct offset. I mean, it's still there. It's just that you have what you basically have. Okay, so next one, right? So it's still not the main address, right? So, we do again, but this time we're gonna find out what accesses this address, right? So we did what access it, and we're going to change value again. Okay. So here's a little bit of a different instruction, RSI into RSI. What does that mean? It basically means the same, like it's on the same offset. It's in the same location, right? So I'm going to pause it and quickly write it out for better to understand it. I kind of fixed a little bit of how the diagram works. So in a way, think of these are all like memory locations and sections, right? And pointers kind of dictate how you should traverse this like tree map in a way. And here we started at the house, right? Let's make it a little bit more consistent. We started at the house, we have the value inside of it, and this is what we want. We went back, and the way this section of code knows to go here is our pointer points to it. The value of whatever's inside is just going to take you to the top memory, right? The top area of the memory that it's trying to find. And it won't be the correct number. Now, if it's a level, like a 0 level kind of pointer, it will, right? If it's just a one specific level, then it will be fine. It will point you and it will give you the right direction. But a lot of times it's not. It gives you by offsets. And this is where you'll end up to get the correct address. Now, what we're trying to go is we're going to try to go back this way. Now, we don't know if, for example, this address, for example, it has, let me duplicate this. It has like these sections on top, right? Or if it's below, or if it's the head of it, right? We don't know if there is an offset or if there isn't, right? So right now, I'm gonna put that right here. Let's assume there isn't, right? Assume we're in a scenario where there is no offset, right? And this is actually what's gonna happen in the next section right here. So we know we have this address, right? Right, so we found the address, so we know that it's getting access. Something goes through it. Okay, so let's look inside. Find out what access it. Okay, great. So we did the same thing we did for this, but we're now doing it for level 1. We're trying to figure out what's happening in between level 1. Right? So we do the change value again. We see the RSI and RSI, like we saw before. Okay, so we know that the value, the address in the value we're looking for is the same. So basically the value in what we're looking for is the same as the address that ends up being on the level 1. So the value in level 2, right, the value will be in here, will be the same as the value in the address of value level 1 will be the same as value 2. So what we need to do is essentially basically search the same address, right? We search for the value of that address like we did in step 6, I think it was, step 5. Essentially, we grab the same address because it probably doesn't have, like based on the instructions, doesn't have any offsets. We do a new scan, right? And we put the same address in there because we know that there is no offsets. It goes directly to where it needs to go. First scan, there you go. So this would be now our level 2, right? Now let's go back and where's our thing? And explain how this whole thing works. We just searched for the level 2, right? This would be our address for it that we got, but we searched for the value, right? We searched this value right here, also this value, right? Okay, so what happens in this scenario? Well, in this scenario, essentially, in a way, the pointer doesn't actually give you the signs to a specific area, right? So the pointer there is still a pointer here, right? It's still, right? So the pointer points from this again to this, right? In a way, right? Like the sign still takes you to the correct one. So the pointer's job, he's still kind of directing, hey, this value is dictated to go here, right? To go, so like, for example, this address will be dictated to go to this address. So this pointer is still there. It's just that it's not actually offsetting from everything. So the sign essentially says, go to the neighborhood. Don't go to the house. Go to the direct first house that you see, right? It's telling you to go in the same way. So the pointer still dictates where to go because it needs to know where to go. It's not like this is cut off and it just knows. Well, in a way it has the value, so in a way it does know, but the pointer in most scenarios is still there, right? It's still there. It's just the pointer is not doing anything crazy with the offsets. It's just telling you, hey, I am just like a typical pointer. I'm gonna point from the address to where I'm supposed to be, right, to the start of the memory. Now you can look at it in terms of like this, right? You can look at it like this. Think of it like that. And in here, plus 0x0. Basically, the pointer is not doing any offsets. It's pointing directly to where you need to go, right? That's what it's doing. So essentially, right? Actually, let's do it blue, right? This is in the same function, right? They're doing the same function right now, in a way, right? So even though this has the address to show where this address is, so you can make a code to just compare two addresses, right? And just transfer basically what's inside to the other side. But what's actually happening is just the pointer is not acting in any offsets. It's not doing any offsets. It's a direct pointer, right? It's doing this right now. That is kind of like the best way to give you a low level example of like what's happening. Now let's continue with what we were trying to do. Cheat engine. Okay. So now we have to keep doing this over and over until we reach the final step. I think I did access, right? Yeah, okay. So now we have another one. Another 18. Okay, so this is simple. We take the address, right? So because we're trying to go back, right? We already have the address. Okay, how do we go back? We have now directions. So there's a pointer that gives us directions. Copy it, put it into your hexadecimal, right? And we know it's we need to find the head of the neighborhood, but it's going down 18. So we have to go backwards 18, right? Minus 18. We have this, okay. And this is what we're gonna search for. Remember to remove, remember to remove this 0 first scan. We found it. Now this is our level 3, okay. Right, and we're gonna do this again, right? And I'm gonna draw it out once we do it again. 10, so this time it's 10. We take that address right here, put it here, minus 10, because it's plus, right? You can see it's a plus. And we do a new scan once again, make sure it's hex, the spacing, and we got to the static address. So level 4 now, right? We're at level 4. And what you can think of it like the tutorial x86 exe, right? Think of it like that's the base module address of the DLL you're running. So when you launch a program, it's a DLL, a library that gets allocated with some memory, and the computer or the cheat engine knows, okay, well, look into this process, there's probably has like an address that is the base module addresses, and here's the offset of where the memory is going to start, right? And then you do all these pointers and back, and basically the base address is this, is the tutorial x86 plus this offset within it. So there's an offset within the base address itself, but you don't know what the base, like what the original address is going to be. You just know that, hey, it's going to be at this exe plus whatever in memory, and which is that plus 325B00, right? So I did not know why I doubled it, but essentially this is the address that is right now, right? It's the 1A8B. This changes too, because when you launch this, right, this itself is different every single time as well, right? The exe itself has its own value that it adds to it, right? And cheat engine looks at it, looks at where is it in the memory, and then it adds this relative offset to it, right? To get the base address of it, of where the memory starts for it. And this is what you're looking for. So to describe what is happening, and we'll try to do it as quickly because I don't want this video to be too long. That's already. So we left off at C8. Okay, so we left at C8. And we got to our base address, right? So these are the offsets that we have right now. So let's kind of visualize what's happening. Right, I'll pause. We'll pause right now. I'll quickly do it and we'll come back to it. Welcome back. So what I'm gonna do before I show what's back here, right? To make it a bit easier, let's kind of do it like this. We're gonna try to create our pointer to our health. So from the base address that we found, we're going to create a pointer that will then, anytime we launch this cheat engine, it can follow the path of the pointers and the signs, or like pointers, think of it like signs. Or I would say think of it like more like mailboxes, because like double-ended one where you could put mail in and then the other person can take it out, and the other way, right? So think of it like, but the easier way to understand is a sign in a way, right? And we're going to manually add this pointer. We know to get to the base addresses, we needed to go from the value 1, 2, 3, 4. So there's going to be 4 offsets, right? Why did it do that? Oh, yes. Hold on. Let me grab this. I hope. Right. So we start with the base location where it points to. So basically our main address, right? Our main module, it gives a specific address, and it's a pointer that's going to point to some address. That address has some value. And then we're gonna offset. So we have to go backwards. So level 4. So that will be x10. Then it's gonna be x18. Then it's gonna be x0. And then it's gonna be x18 again. And we click OK. Now see, a pointer to health. Now we have a pointer that directly follows the steps, follows the path from the base module, from this base module plus its own internal offset, to whatever that pointer points to. Follow the chain until we reach where in memory we store the health value, I'm guessing, right? Or it's just value. What did we put? It's just value, but okay, let's assume it's health or something like that. Now, let's actually visualize what are we doing? What we just did. So, start backwards. This is where we're trying to get some value, right? It's 3 something else right now. What is it now? 3180. It's 3180. 3180. Right, so now it's 3180. What did we try to do? Okay, so what we're trying to do, can I show it? Yes. So essentially, all these steps, right, that you see from here is these offsets. And to explain it better, Windows basically assigns the exe of the module you load at a memory point. You never know what memory point is because Windows runs and there's different memory addresses that go through registers. So, but it needs to, right, tell it where it is, right? There's supposed to be some kind of address to understand how everything works so it can reference each other. Okay, well, Windows assigns it somewhere. It assigns the starting point, and we know that the pointer, the main base pointer where all this chain starts, specifically to get to our health at least, starts at tutorial.exe plus some internal offset, right? So it's this one, right? So this is the main start pointer address, right? But this number will be different. So you need to know this, and you need to know the offset. This is technically your base address, right? You never even know what your base address is in terms of like actual like memory, right? You just know that, hey, from exe, when you start, go to this area, and this is where you're starting, right? So think of it like, okay, I am in America, right? I am in America. This is our tutorial. Okay, we'll go to this state, right? Go to California, right? And this is where you'll start. But let's say America, for some reason, is now in the middle of Europe, right? Well, we're still in America, right? It's just that all of a sudden somebody grabbed America and they put it in the middle of Europe. But we still have to go to the same state, right? We still have to go to California. It's just California might now be in Portugal rather than in where California used to be. So this is why this is always changing every time you launch. And when you start, when coding goes through, memory goes through, it assigns some value, right? It's a pointer, right? This address is simply just a pointer as well, right? It holds a value of another address. And the instructions of the pointer right now, currently, is to offset to find the other value. So even though it's holding the value, right, to the start of some memory, right, to the first level of our pointer, we don't want the start of that memory. We want the pointer to point 10 offsets off of where it was. So even though we have the value of this, the pointer's instruction is to offset from whatever you have in this value to not go to the main start of the name. Let's think of it like, okay, hey, we're in California. We started in California, but specifically, we want to get to a county in, like a section in California, right? Well, we don't want to go to just where it says welcome to County 1, right? Welcome to County California, welcome to Wasaga Beach or something like that, right? We want to get to we don't want to get to the sign of it, right, where it starts saying welcome, you're entering Wasaga Beach type of thing, right? I don't know exactly what the county of Wasaga Beach is, but let's assume that's what it is, right? You don't want to start there, right? We want to get to because maybe, right, think of it like this. Even though you got to the sign of it, well, the sign might not be where you need to be. It's the start of the road, right? It's just the start of it. You have to keep going down the road, go through a bunch of intersections and get to it. Well, this one tells you right away, hey, go to this intersection, because this area, this intersection will tell us where we need to go from to the next major point, next major area of our memory. Now we're, instead of searching by county, right, this is think of it like counties, right, different areas or different regions within California. Well, we don't want to keep searching regions. We know what region we want. We don't want the starting region, the first region they ever created in California. Think of it like a directory, right? In the directory, the Wasaga Beach is there in number one. It's no, we know what specific one we want. We want, I don't know, Hollywood or something like that. We know we want to get to Hollywood right away. We know in California, we don't want to go to Wasaga Beach, then go one by one by one. We know we might start in Wasaga Beach, right? Because maybe it's in the directory, it's the first one directory, but we don't want to. We want to offset it to Hollywood type of thing, right? So we want to offset it to address 4. I guess, yeah, we went backwards. So we want to address in the first one. Well, that one is also a pointer and it has instructions to do the same thing. So now in Hollywood, let's go to specifically, not to the letter H, but to the first letter L, right? Right, Hollywood, right? So let's go to the letter L, right? So now we don't want to go to the start of H. I don't know, thinking about county might be a little bit harder, but let's say a section of Hollywood. Instead of going by, not the sign, let's not do the sign. Let's say assuming there's I don't know, in California, assuming there's a region of Hollywood, right? It probably has blocks, right? So blocks, right? So think of it like blocks, blocks of houses, right? So, and we know where these blocks of houses supposedly start, right? But we know specific which block to go to, right? It's 18 blocks, 18 offsets away from the first one that is in the directory. And we have the pointer that will point us to it, right? So if we want to reference back to our cheat engine, right? We started at this address, right? So right here, we started at this address. We went into California. We went into California, right? So assuming let's say this is America, right? And it's this is Washington, right? Washington, the state, Washington, or whatever is the first one. But we don't want to go to Washington. We want to go to California, right? We went because it's in a directory 3. Then in California, we want to go into specifically Hollywood. I don't know if there's an area in Hollywood, right? But we want to go to the Hollywood. We don't want to go to, let's say, Wasaga Beach, that area of California. We don't want to go to there. We want to go to the Hollywood area. Okay, cool, right? It's still regions, right? Assuming these are regions. But within Hollywood, I'm sure there's blocks, right? There's blocks of houses, and they might be named, right? I'm not sure how it is there, but they might be named by blocks, right? This might be block A, block 2, block 3 of houses, right? And in this scenario, right, because we're at 320, right? So now we're at 320 right here. In this scenario, where we want to go is actually turns out to be the first directory, right? So there's no need to be offsetting anything, because the first thing that pops up in our data that we need to go to is where we want to be. So it's as soon as you say, okay, I want to be in Hollywood, but I want to get into the blocks. I want to get to the blocks of houses that are in Hollywood. And as soon as you get in, the instructions tell you you're there. You don't need to keep going down the street to go to the blocks of houses, number 3, number 2. You're there. You're already there. This is what's basically happening. Your pointer just says, yeah, I'm pointing you, but you're already there. So technically, I'm just pointing you where you're already there, right? Like I'm going to point you to the blocks and you're here, type of thing. While these ones are more like, I'm going to point you to the blocks. So you're starting here, but to get to the right place, go down 18 levels, 18 offsets, right? But in this one, okay, you're here. Let's go down nowhere, right? It's still pointing. It's just telling you you're there already in a way, right? So this would be, see, like if you can look at the numbers right here, you are at 20, right? Oh, sorry, we're already here. Sorry, yeah. So it just points you to the address, right? And we are basically right here. So because 320 is the address and the value of it is. Okay, so now we're in the final step. Okay, we are in these blocks of houses. We have a pointer. We have the last pointer there. What do we do? Like, how do we get to the house I want? I want the house that has the value of my health or whatever value I need. What do I do? Okay, well, you have the map, right? Right, once you get there and the sign says to get to where you want to go, it's going to be in this section starting from here. And the pointer will give you an offset, right? And it will tell you, you need to go here. And then from here, I need you to look for the house number 18, right? So you go to this neighborhood, right? Go to here in the blocks of houses, go to this section, like this building, right? Let's say it's apartments, right? Let's say it's a neighborhood, right? So a neighborhood within the block. And that block has 10 houses, or so that area has 10 houses, while another part of it has another 2 houses, right? But all of this is just one block, right? Let's say one of them is like an apartment building. One of them is an area with 10 houses. One of them is an area with like the food stall, right? There's three stores there, right? So that would be a different area right here. And it's telling you, okay, I need you to go to this area of houses. And the one you're looking for is 18 down the line from where you start. And this is what this pointer is telling you. This pointer will tell you, okay, we will start here, but we will offset ourselves from 18 to get to the house that you want. And the final step that we do is basically ask, okay, we're in this address. We finally got here. The pointer got here. What's the last thing we need to do? Look inside that house and you find the number 383180. Right? I hope that made sense. First time explaining it. Hopefully I might not got full all of it, how it works, but essentially this is what this step is trying to teach you. Okay. So and what they want us to do is essentially set it to 500 or 5,000. Then freeze it. Change pointer. You got 3 seconds. Oh, I think. Yeah, I think they put a little timer in case you didn't freeze it or something. But yeah, if you freeze it, it just stays at 500. Right. So here's where, don't get confused. You see how it says I'm changing the value? You can even, does it show up here? It basically tries to change the value to 1845 and it displays it right away. But what this freeze does is that it changes it back to 500. So basically what happens is the value is 5,000 right now. You press this value and it will change it to another value. It will display it and then the freezing point changes it back to 5,000. So you will never actually see it's 1845. So to change this to the correct value you need is you basically have to also intercept whatever data is used to show the value. There's values to store and there's values to display. And sometimes things that you change for display won't actually translate into what is stored, right? So they're not sometimes the same thing. Sometimes you need 2 values for display, 1 value for this. Okay. If you change the pointer, it will still be the same, right? So when you change the pointer, you see what we did here? You see how it now reads to this? To explain what actually happens, what it does is very simple. It cuts off this entire area, but it remembers these instructions. So it's not gonna remember this, right? It's gonna remember these values, like these offsets, and it's gonna start again from the base address, and it's gonna repeat. I don't know if I can do it. It's gonna repeat. Okay, but assume these are all different addresses now. It's gonna repeat, but these memory addresses are now changed, but you're still gonna get to the correct value. And that's how you do it.